Hello friends, welcome to our channel Knowledge Amplifier, and in my this particular video I am going to introduce you with a very frequently used term in machine learning, and that is curse of dimensionality. And I am going to introduce this term with respect to decision tree algorithm point of view, right, for the time being. But this particular curse of dimensionality is applicable for many machine learning models wherever this particular problem arises, which I am going to discuss now, right? So if you have seen my previous videos where I have discussed in detail how regression tree and classification tree forms, then you might have seen the two algorithms are almost similar, right? Like for regression problem, what we do, first we consider all the predictors and all possible cut points values, okay? Then we calculate residual sum of square for each possibility and we select that one which is having least residual sum of square. That is, we follow greedy kind of approach. We never consider that what the final decision tree is going to be look like at a particular stage, for which cut and for which feature I am getting least residual sum of square. We are going to choose that. That is greedy approach, right? So we are choosing like this, and we will continue the same process until one stopping criteria is met. That might be minimum observation at internal node, that might be minimum observation at leaf node, that may be maximum depth of my decision tree, we can specify, right? Now for classification tree formation, instead of RSS we use the concept of classification error rate, okay? And as you know, the prediction methodology for classification is mode for a region, whereas in for case of regression tree, mean is the methodology, right? So this is what I have already discussed. Now just have a recall of the classification tree formation. So suppose I am having only two input feature. One is total number of hours studied per day and a midterm score for an individual student, and based on this we have to predict whether a student has passed or failed in final exam, okay? I have put roughly all the data points whatever was present in my data set, right? And this is my scale. And now what we start with classification tree, like step one is consider all the predictors and all possible cut points. And like for hours, if we start, first thing we start with suppose greater than 5 less than 5. Based on this we are taking decision, okay? The data points having these labels, this is fail and P for pass, right? Then what I have told you, that for classification tree for this whole region our model will consider one single label, and that is mode of this particular region. Mode of this particular region is going to be fail, obviously, because only one data point is present. Mode for this particular right side region is pass, right? Now what is the misclassification? See, in the left hand side no misclassification because mode is fail and our only one data point having fail as label, right? But for the right hand side, if you consider 3 pass but 2 fails are present, but for the right hand side the mode class is pass, so basically these 2 fails are basically misclassified, right? So misclassification rate, if you consider 2 by total number of data points, right? That is total number of misclassification by total number of data points. Like this, it is calculating misclassification rate when it is taking decision based on hours greater than 5 and less than 5. Like that, it will try for hours greater than 6 or less than 6, then it will try for hours less than 7 or greater than 7, then it will try for hours greater than 11 less than 11, then same for 14, then for 18 hours. Now this is only for one feature. For midterm feature also it will try all possible combination, like greater than 35 less than 35, greater than 40 less than 40, greater than 42 less than 42, greater than 50 less than 50, greater than 65 less than 65, like that, right? And then for all these possible combination for which we are getting minimum classification error rate, it is going to choose that particular feature and that particular cut value for that particular decision in that stage, right? So you can understand that there is a huge computation for deciding only one particular feature and corresponding value, okay? For one stage there is huge computation. And you just think this is for only 2 features. Suppose in my dataset there are 5 features, and suppose there are 100 distinct values for each feature, then 500 there is 5 features, and for each features 100 different combination, so total 500 possible combination it has to try. just think for one single stage what is computational complexity, right? So as the number of features will increase, obviously what is going to happen? Obviously training the model will take huge time, right? So this is only I have discussed the first stage. Suppose in first stage we got this particular as best possible cut for which misclassification rate is minimized. Okay, there is midterm score greater than 42, less than 42. Now for these two regions separately we have to apply same algorithm until the stopping criteria is met. So what I want to tell you, that is, if the number of features increases, you can simply understand the training time is going to take more and more. Okay, and this is what is parts of dimensionality. Dimensionality means it is indicating number of dimension or feature input features. Okay, parts means, I hope you know this, what is the meaning of parts. In Hindi we say this sap or abhishap. Okay, so due to dimensionality increase, whatever problem we are facing, that is denoted by this particular beautiful term, curves of dimensionality. Okay, that is difficulty that arises when analyzing or organizing the data for higher dimensional space, which is having higher dimensional space. Higher dimension means more number of features. Okay, right? So we have seen in case of decision tree, it has the problem of curves of dimensionality. This is a huge problem, and for this you should remember these 2 points. Okay, as I have discussed, that as the dimension increases, the computational time for training also increases, and that's why decision tree may not be suitable when you are having higher dimensional data, that is more input features. Okay, so I hope you have understood this, that is parts of dimensionality with respect to decision tree point of view. This is all for this video. If you find this video helpful, please like, share and comment. Subscribe my channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of my latest videos. Thank you for watching.